Next is the second law of thermodynamics. Now, what actually is the second law of thermodynamics and why was it needed when we were already having first law of thermodynamics? What was the need of second law of thermodynamics? Second law की आखिर ज़रूरत क्यों पड़ी? So, just understand this thing, students, that first law talks about is law of conservation of energy. It says that energies are mutually convertible. That means heat can be converted into work, work can be converted into heat. But first law didn't give us the direction of conversion, in the sense that there are certain processes which are possible in single direction whose reverse direction is not possible, and there are certain processes which may occur in reverse direction as well, but with certain limitations. So, what are those limitations? Those were not told by the first law of thermodynamics. So, for that we need the second law of thermodynamics. So, second law of thermodynamics is actually the directional law. It gives us the direction. I will tell you with the help of one example. For example, let us suppose we consider that paddle wheel arrangement as we considered in the Joule's experiment. Okay, so we are having one stirrer inside a closed vessel, and which is connected with the help of pulley to a weight. Okay, when I am dropping this weight, what will happen? This stirrer will rotate. That means we are doing certain work on the system, and as a result of that, the energy of the system will increase, the temperature of the system will increase, because this is an insulated vessel. Now, just understand this thing now. Now, if I am removing the insulation, what will happen? Now, because of difference in temperature, the energy will flow in the form of heat. Now, if I ask you to use that energy, to use that heat and again lift this weight up, because initially what we did was that work was actually converted to heat. Now, if I ask you to convert this heat to this work, I ask you to convert this heat and just use this heat in order to raise this weight. So, is it possible? No, it will not be possible. So, this is the process in single direction only. Another example I will give you. Let us suppose I am having a block and I am pushing this block on a rough surface. Now, what will happen when I am pushing this block on the rough surface? I am putting certain energy into it, which is converted to the kinetic energy of the block, and that kinetic energy of the block is finally converted to heat. Because of the friction, it will stop after a certain time because of friction, and that kinetic energy is actually converted into heat because of friction. Now, if I ask you to use that heat and move this block again, will it be possible? Of course not. So, these are all processes which are occurring in single direction, whose reverse direction is not possible. On the other hand, there are certain processes which can occur in reverse direction, but with certain limitation. For example, suppose heat, as we know, flows from high temperature to low temperature. Water flows from high height to low height. That means everything flows from high potential to low potential. So, that is a natural process. The heat will flow from high temperature to low temperature naturally. Now, will it be possible that heat flow from low temperature to high temperature? Yes, it will be possible, but with certain limitation. We will have to do certain work on it. If we want to push water up to a certain height, because water ऊपर से नीचे तो directly आ सकता है, but अगर हमको उसको नीचे से ऊपर ले जाना है, what we will have to do? We will have to use one pump, and we are using one pump. That means we are doing certain work on the pump in order to pull the water upwards. Okay, so these are the processes in which can occur in one direction and which can also occur in reverse direction, but with certain limitation. It will consume some work. Without consuming some work, it will not reverse. That process will not be reversed. Okay, so all these things are told by second law of thermodynamics. Okay, next important thing is work is the high grade of energy and heat is the low grade of energy, in the sense that complete conversion of work into heat is possible. Complete conversion of work into heat is possible. For example, suppose I am having an electric resistor and the current is flowing into it. That means we are doing certain work on this, and as a result of that, the heat will be generated. Okay, so whatever work we are giving, that complete work will be converted into heat. That complete power which we are giving, I square RT, that will be converted into heat. Okay, so that means complete conversion of work into heat is possible. That is why work is the high grade of energy. But complete conversion of heat into work is not possible. For example, again we are considering the piston cylinder arrangement example, which we considered in the previous units. Okay, so what we are doing is we are supplying some heat into this arrangement. So what will happen? The piston will move, we are getting certain work out of it. Now, whatever heat we are supplied, we will not get the same work. Okay, the work which we are getting, which we will be getting, will be somewhat less, because as you have seen, Q is equal to del U plus W. That means some of the energy is utilized in doing work and the remaining energy is utilized to increase the internal energy. That means whatever heat is supplied is not completely converted into work. Okay, so heat is work is a high grade of energy, complete conversion of work into heat is possible, but heat is the low grade of energy, complete conversion of heat into work is not possible. So these are few backgrounds of the second law of thermodynamics. Now before actually getting into the official statements of second law of thermodynamics, let us first discuss about heat engine. What is a heat engine? So heat engines are the device which continuously produces work at the expense of heat. That means in heat engine there is net heat transfer to the engine and net work is delivered from the engine. That means it is continuously producing work at the expense of heat input, that is heat engine. And in order to continuously produce work, as we know that heat and work are transient in nature, transient phenomenon. So in order that work should be continuously extracted, it is essential that the process which is occurring inside the heat engine, that should be the cyclic process. So this heat engines are referred as cyclic heat engine, that because the processes which occurs in the heat engine is the cyclic process. And the cycle which is executed by heat engine is known as heat engine cycle. For example, the engines which are used in automobile, the IC engines, this is an example of heat engine only. What happens in the IC engine is the heat is produced by the combustion of fuel there, and that heat is finally utilized in order to produce some work. Okay, so and that is a continuous cycle, that is a cyclic process, we get continuous work out of it, that is a heat engine cycle. Okay. Next, again if I give you the example of an open system, so the power plant is an example of heat engine. Okay. The power plant, as we know, what happens in the power plant, we have the boiler. In boiler the water is vaporized, the high temperature high pressure vapor is produced, that vapor is finally passed through the turbine, the work is delivered from the turbine, the remaining vapor is passed through the condenser, it is finally condensed to the water, and that water is again pumped to the boiler, and this is the whole cycle. This cycle continues and it continuously produces work in the form of electricity, as we know. Okay, so this power plant is also an heat engine. Okay, so what happens what is basically happening in this power plant is, if I draw the border here, so this heat engine is taking heat from the source, which is boiler in this case. Okay, so this is taking, let us suppose, Q1 heat from the source, and this is delivering Q2 heat to the sink. Q2 heat is rejected from the condenser. Okay, so this heat engine is taking net heat from the surrounding, and it is producing net work from turbine. The W turbine is produced, in pump WP pump work is consumed. Okay, so this is whole heat engine. Okay, so if I tell you about this heat transfer, total heat transfer Q net, so as you have seen is nothing but Q1 minus Q2. Q1 heat is transferred to the system, Q2 heat is rejected from that heat engine or from the system. First thing. Now what is the net work delivered? So here WT turbine work is produced by the system, so it will be taken as positive, and WP pump work is done on the system, so it will be taken as negative. Okay, so this W net will be equal to W turbine minus W pump. Now we know from first law, as we know, cyclic integral of Q cycle, summation of Q cycle, should be equal to summation of W cycle. Okay, or you can say from here, this will be equal to Q1 minus Q2, this will be equal to W turbine minus W pump. Okay. Now what is the efficiency? So efficiency is, as we know, is output upon input. The output from this heat engine is nothing but W net. We are getting W net work output from the heat engine, and the input we are supplying is Q1. With the help of boiler we are supplying that input is Q1. So what will be efficiency, which is output upon input? So this will be equal to W net by Q1, or you can say this will be equal to WT minus WP by Q1. Okay, or you can further write it as Q1 minus Q2 by Q1, or you can say this efficiency will be equal to 1 minus Q2 by Q1. So this is the efficiency of a heat engine cycle. So this whole heat engine, if I summarize this thing, this whole heat engine, what this heat engine is doing, this is taking Q1 heat from the source, which is a high temperature source, this is rejecting Q2 heat to a low temperature sink, and it is producing W net work done. Okay. Now here two terms I have used, that is source and sink. Okay. This source and sinks are nothing but the energy reservoirs. These are the thermal energy reservoirs. Now what is the reservoir? Reservoir means, the thermal energy reservoir means if any amount of heat is added to that reservoir, or if any amount of heat is extracted from that reservoir, the temperature of that reservoir should not change. reservoir हम किसको बोलते हैं? Let's suppose for example the water reservoir, जैसे कि lake हो गया. Okay, so what is the lake में क्या होता है? If I am taking suppose 2 bucket of water, तो क्या उसका level गिर जाता है क्या? नहीं. Similarly, reservoir means if I am taking a finite amount of heat from that reservoir, the temperature will not suffer. Similarly, if I am dropping finite amount of heat to the reservoir, the temperature will not suffer. That is nothing but reservoir. So this reservoir, as I told you, is of two types. First is the source, second is the sink. Source means any amount of heat can be extracted from that source and temperature of that source will not change. Sink means any amount of heat can be rejected, can be added to that sink and the temperature of the sink will not change. Example of source you can say is sun. Sun is the best example of source. Continuously the heat is getting transferred from the sun, but still the temperature of sun is not affected. Boiler furnace is also an example of source because it provides continuous heat without sufficient change in temperature. That is the example of source. Now what about sink? The example of sink you can say is atmosphere, because if I am removing heat, I am releasing some heat to the atmosphere, obviously the temperature of atmosphere is not going to change. Okay, so this is nothing but the thermal energy reservoirs in which any amount of heat can be added, or any amount of heat, when I say any, obviously I mean some finite quantity. It may be large enough, but still a finite quantity. So if any amount of heat can be added or rejected from the reservoir, the temperature of reservoir will not suffer. So heat engine, as I say, is taking heat from the source, is removing heat to the sink, and in this process it is producing some work. Now what if I am not taking the thermal reservoir, if I am taking certain body in place of reservoir? Bodies means whose temperature will change. If I am removing the heat from the body, the temperature will drop. If I am transferring heat to the body, the temperature will rise. Okay, so what if I am replacing these two reservoirs with two finite temperature bodies, a high temperature body and a low temperature body? Now what will happen? Now work will produce till the point when the temperature of both bodies are same, because when I am extracting heat from the high temperature body, the temperature will drop. When I am passing heat to the low temperature body, the temperature will rise. Okay, so till we are having the temperature difference, obviously the heat will flow and we will get work. As soon as the temperature of the two bodies are same, we will stop getting this work. Getting this? Next is coming to the official statements of second law of thermodynamics. So the very first statement is the Kelvin-Planck statement of second law. Now what is this Kelvin-Planck statement says? This says that it is impossible to produce net work in a complete cycle by exchanging heat with single reservoir. I am repeating it again. It is impossible for any device to produce net work in a complete cycle by exchanging heat with single reservoir. Very very important thing. Now what does this mean? This means that किसी भी heat engine के लिए या किसी भी device के लिए ये possible नहीं है कि वो single heat reservoir से heat exchange करके work produce कर सके. As we have seen heat engine में, we have seen that there is a source, there is a sink, the heat is extracted from the source, heat is rejected to the sink. Okay, and that's what Kelvin-Planck statement says. It says जितना ज़्यादा source important है उतना ही ज़्यादा sink important है, जितना ज़्यादा heat लेना important है उतना ही ज़्यादा heat release करना important है. That means there can be no device which can produce net work in a complete cycle by exchanging heat with single reservoir. And such fictitious machine, why am I calling this as fictitious machine? Because in actual sense it cannot exist. Such fictitious machine which exchanges heat with single reservoir and produces work is known as PMM2, perpetual motion machine of second kind. We have seen about perpetual motion machine of first kind in the first law unit. Now this is perpetual motion machine of second kind which exchanges heat with single reservoir and it is producing continuous work without rejecting heat. Now what does this mean? If we are having certain device which is continuously extracting heat Q1 and continuously producing work W without rejecting heat, then obviously according to the second law that Q1 will be equal to W. Okay, and what will be efficiency? Efficiency, as we know, is W by Q1. So since Q1 is equal to W, so efficiency will be equal to 100%. Okay, which actually is not possible according to Kelvin-Planck statement of second law. That means there can be no device which is having 100% efficiency. Even Carnot cycle is not having 100% efficiency. ओके सो जितना ज़रूरी हीट एडिशन है किसी साइकिल के लिए उतना ही ज़रूरी हीट रिजेक्शन है. विदाउट हीट रिजेक्शन you cannot assume that net work will be produced in the complete cycle. This is what Kelvin Planck statement of second law says. Okay, next is the Clausius statement of second law. Again, very important thing. Now what does this Clausius statement says? This says that it is impossible for a device to transfer heat from a low temperature sink to a high temperature source or from a low temperature body to a high temperature body without some external work done on it. Now what does this means? This means, as we know, that heat, the natural flow of heat is from high temperature body to low temperature body. हमेशा किसी भी चीज़ का जो नेचुरल फ्लो होता है that is from high temperature to low temperature, from high potential to low potential. But if we want to transfer heat from low temperature to high temperature, then certainly we will have to do some work on it. That means it is not possible for any device to transfer heat from low temperature body to high temperature body without consuming an external work. This is what Clausius statement of second law says. This means heat cannot by itself flow from low temperature to high temperature until and unless we are doing certain work on it.